Good morning, creative coders. At least, well, it's the morning as I'm recording this. I don't know when you're watching this, but I hope it's good whenever it is. Today, we're going to be talking about Tracery, which is a library for doing something called a context-free grammar, and you're going to be using that to create your version of a poem called House of Dust by Allison Knowles and James Tenney. So in this video, I'm going to be talking about these things. I'll talk about the poem first, House of Dust. I'll talk about what a context-free grammar is. I'll introduce you to Tracery, and I'll show you how to use it in completing the Houses of Dust exercise for this class. So House of Dust is one of the earliest computer-generated poems, not the earliest, but one of the earliest kind of well-known computer-generated poems. This is an example of one of the printouts of it. It was programmed in Fortran. It would have been run on one of these gigantic time-sharing computers, mainframe kind of computers, maybe not even time sharing, but a mainframe kind of computer, punch code, Fortran written out and then coded on punch cards, then fed into the machine, and then you would get this output. It takes a couple minutes to print the entire output of it, or to print a good chunk of output of it, and it's an interesting poem. It's composed of a specific set of possible variables that you'll see as you kind of look into it. Allison Knowles is a poet who is affiliated with the group known as Fluxus, and they had a playful approach and a performative approach to art and language and music and performance. And so there's a sense of play or a sense of openness to these stanzas or quatrains. And so as you read these, and as I read a few of these out loud, think about what this house is like as I describe it. So a house of steel in a deserted church using electricity, inhabited by various birds and fish. A house of glass in a desert using electricity, inhabited by friends. A house of weeds in a desert using candles, inhabited by people who sleep very little. Notice as I read that, the indentation creates a kind of rhythm, a kind of pausing between each line, and I think that pausing kind of gives you as the listener just a moment to imagine what that house would be like. What would a house of steel be like if it was in a deserted church? Is that a literal house? Is that some kind of metaphor? Notice that using electricity occurs in both of these. As you look at the code and as you look at outputs of this poem, there are fewer options for the light source line, for the third line, than there are for the other one. So you'll see using electricity, using candles, using natural light more frequently than you will see some of the less common options in terms of the types of people, for example. There's lots of different kinds of people. So that's a bit of it. So looking at it again, this is a poem that, in its original form, well, one version of it that was distributed, published in Germany, was a stack of this. This is called continuous paper when it has the circles on the outside there. That's for the gears of the printer to roll it out. That kind of paper. A version of this was printed and distributed as a book in Germany, and what they did is they just ran that printer and printed out like 25,000 pages of it. It was a 5-foot stack of paper, and then they just kind of sliced it into pieces, sliced that stack into pieces, and then bound those as books, or distributed them as individual copies. And so, but they're not really copies because each of them would have been unique. So a really interesting experiment in art book publishing beyond the experiment in poetics as well. But as an experiment in poetics, it demonstrates this whole, I think, this interesting tension between intimacy and scale. So when we think about what would it mean for there to be a house of weeds among high mountains using natural light inhabited by very tall people. So as we are invited into each of these spaces, we can imagine that space, we can think about the kind of people there, we can think about what it would be like to be there, we can think about, is this a metaphor? We can think about all these things intimately and individually within each of these quatrains, or we can think about the just enormous scope of this poem as this gigantic stack of paper that's being output by this relatively simple program. And so it's one of these fascinating things about digital poetics. So one of the things that's interesting too is that in the 1960s, Allison Knowles, James Tenney, the Fluxus group, they were interested in performance and experiential art, experiential poetry. And so there were two different instantiations of houses of dust built by choosing a quatrain from the output and then trying to build or create that house. And as you can see, this is a picture of one of them. It's not a conventional house. It has some unusual shapes to it. And as you read these quatrains, they are often kind of unusual houses. So thinking about what they would look like or feel like to be inside of, it's kind of different. Unfortunately, this one was destroyed by arson, but there is, I just found this in looking at and preparing the notes for today's class. There is one right now, actually, in Germany. An artist group called Tiny Bee it made this one, and I what I gather is that they did a crowdfunding campaign to produce this. It seems to be an art group focused on experiential kind of interactive inhabitable art, I guess. And so this is what you're seeing here is a 3D concrete printer making this house, and it's like as an art exhibit. It opens next week, actually, as I'm recording this. So kind of interesting that this is a continuing thing that people, it's not just me coming up with things for you all to do in this class. This is an interesting thing that people are doing and working on in an ongoing kind of fashion. Well, like any poetry, I think it's good to hear it. And you heard me read a few lines just then. Alison Mills herself has also performed this piece many times, and you can find many of those on YouTube if you search for them. In the notes for today, and then in the next slide, I'm going to pause that first. I will play a minute or two of her reading the poem at the White House in 2011.
I'd like to read
hide myself.
Just a little of a poem called The House of Dust, which is one of the first computer poems ever done, if not the first computer poem. So I'm going to read you a little of this. This is programmed by a wonderful composer in California, James Tenney. A house of brick by a river, using candles, inhabited by children and old people. A house of tin in a hot climate, using electricity, inhabited by little boys. A house of wood on an island, using natural light, inhabited by women wearing all colors. A house of discarded clothing in dense woods, using electricity, inhabited by collectors of all types. A house of brick in a green, mossy terrain, using natural light, inhabited by all races of men wearing predominantly red clothing.
All right, I'm back. So, yeah, what you hear in that, I think, is how there's so much delight in these different houses, and so much imagination goes into that. And there's definitely a sense of playfulness to Alison Knoll's poetry in general. In the video before this one, she reads Shoes of Your Choice, or she performs Shoes of Your Choice, which is not so much a poem as it is instructions for performing and improvising a poem on the spot. And it's a fascinating thing to try to do yourself. I've tried to do it. It's hard to perform, but a really fascinating and intimate kind of experience to try to go through in front of an audience. So I recommend watching the whole video to get a sense of her style as an artist and poet. So that's the House of Dust, and hopefully that's interesting. Hopefully that's inspiring as you think about how you're going to approach this exercise. In terms of the exercise, the technical concept that we're going to be working on here is something called a context-free grammar. We don't need to get too much in the weeds with this, but I want to kind of talk about it a little bit. This concept was first described by Noam Chomsky. You might be familiar with Chomsky as a political an activist and speaker, philosopher, but his I think arguably his major intellectual contribution in the 20th century was to linguistics, and specifically the foundational concepts for computational linguistics. And one of his ideas is this idea of a formal grammar, or defining language as a formal grammar. So what we see here is just a map of a context-free grammar. So this is actually a complete way of mapping out a sentence, and it has to do with production rules. So a sentence, as you see on the left side, oops, I can't actually highlight this. On the left side, the left side over there is then the arrow has to do with producing it. So you produce that sentence by taking a noun phrase, and then it's noun phrase plus a verb phrase. And then you make a noun phrase by making adjective noun phrase, or the pipe means or adjective singular noun. And then you make verb phrase. So it's rules for expanding each of these things into something. So eventually, whenever you get to something that does not have angle brackets around it, then you finally got word. So you've got an actual sentence. So this formal grammar here would only be able to produce a sentence like "a little boy ran quickly," so, or "the little boy ran quickly." So that's all that this could do. It could do a couple of other odd rearrangements to that. This is meant to be just kind of a simplified view of it, but this is the idea of a context-free grammar, and it sounds kind of abstract when you look at it like this, but it is something that you're pretty familiar with, I think, hopefully, in the form of Mad Libs. My youngest daughter is a fan of these, and these are great things to do on road trips. In fact, I was trying to find one that she had completed recently, and I couldn't find it when I was putting these together. But you can see here, this is just one I found online. This is something you're familiar with. So in this case, in case you don't know, it takes two people usually. So one person has this piece of paper in front of them, and they are asking their friend or friends to supply an adjective, a noun, an adjective, a noun place, an adjective, a plural noun, which is a vehicle, and an adjective. And so it's a good way to learn parts of speech, actually. But it also is a fun thing to do. So once your partner has supplied all of these words without any sense of the context, then you read back to them the paragraph that you've created, and it sounds silly, and you all have a good time. So that's the idea of a Mad Lib. So Star Wars is a adjective noun of adjective versus evil in a noun place far, far away. That's a type of context-free grammar. It has a little bit of context, actually, because it's not purely context-free, but it's something that has that same idea of like placeholders that are put into putting content into those places. Okay, so doing this online, doing this automatically, doing this with computer programming, Tracery is the way to do that. And Tracery is the library we're going to take a look at here. Tracery is something created by Kate Compton, who is a computer science professor and game designer, and creates interesting things with generative concepts in her work, procedural generation content. And her contribution, her invention, I guess, of Tracery is a tremendously useful resource for all kinds of computational creativity. So I'm going to go over here and show you some of what that is and how it works. So this is a Twitter bot I made, and lots of people have made Twitter bots using Tracery, using a system called CBDQ, or Cheap Bots Done Quick, that has been shut down a couple months ago by Twitter. In response to their changes to their API and some other things. And so basically this service, which was created by V. Buckingham, 58,440 bots were created with this system. Twitter bots, these are, for the vast majority of these are literary, artistic, interesting Twitter bots. I've made several with this system. They're all gone now, or they're not gone, but they're shut down. And the way that it works is you define, we'll get into Tracery in a little bit, but you define your grammar. And then this one, this particular bot that I created was trying to take a particular meme, a joke about the TV show House Hunters, where it's you have often a family looking for a house, and the way that the family describes their jobs and the budget that they have based on that job often sounds kind of unbelievable. And so that's the joke, and that's the joke over and over and over again. This just makes that same joke forever. And, I don't find it funny anymore, and that's kind of the point of this bot, I think, is to run a joke into the ground so people stop making that joke. But I guess people still enjoy it. At its peak, it had like 15,000 followers. And the logic for it, it looks like a lot when you look at it this way, but these are really just long lists of options being plugged into that template. So as you read the tweets, you can see the template. It's going to be person one, I do such and such, person two, I do such and such, and them together. Our budget is some number, and that's it. I mean, that's the joke forever. For well, not forever, but for 9,271 times, that's the same joke. So Tracery, I think like I said, context-free grammar, it can be kind of abstract, hard to get your head around. But I think the online tutorial for Tracery helps explain it and also demonstrate, get you using it. So I recommend checking this out. I'll play with it a little bit here, but playing with it on your own is the best way to learn this. And the way it works is pretty, I hesitate to say things like straightforward because it makes sense to me, but I've obviously been using it before, so I know how it works. So of course it's straightforward to me. But let's break this down a little bit. So there's right here, hopefully you can see this on my view here. I'm going to zoom way in. Whoa. Okay, so right here you can see a couple of things. This is a JSON grammar. So JSON is a JavaScript object format. This is something you've seen before, even without knowing the name of it possibly. But what we have here is a name value pair. So here's the name animal indicated in quote marks, then a colon, And then after that, the value. In this case, the value is an array or a list of names: unicorn, raven, sparrow, scorpion, coyote, eagle, owl, lizard, zebra, duck, kitten. These are all the options that can be possible substitutes for the symbol animal. And when this is run, and this button here, when you hit reroll, you'll see that being run different times. So this is running this little bit right here is right behind me is running this grammar here. And sorry, it's kind of there's a little bit of white space to work with here, but it's running this grammar, and you can run it a bunch of times. You can see every time it runs, it picks a different one from that list, or really it could pick the same one multiple times, but in this case it didn't. Or now, it's picked sparrow twice. It's picking. It doesn't know. There's no memory. Each time it runs, it just runs with whatever's there. But here's the real, here's where it really gets interesting, I think. So this is a grammar that has a start symbol called sentence. And if you look into this one, this is actually a string. So it's an array of one element, which is a string, and either way is fine. But the key thing that's different here is if you look through it, it says the color, and the color has hash marks around it, and animal has hash marks around it, and nature noun has hash marks around it, and name has hash marks around it. These are symbols or tokens that are going to be replaced by an element from a list with that name. So for example, nature noun is going to be replaced by a random element from this list here. Color is going to be replaced by a random element from this list here, animal from this list, and name from this list. So every time I roll this one, it's going to start with sentence, and then it's going to start trying to parse out sentence, replacing each part of this until it runs out of replacements. So this can be recursive. This can go down several levels of recursion. So the color list, for example, might have replacements within it that selected other things. And with this kind of system of replacements and possibilities, you're creating a combinatoric situation here, and this is how you can, with a relatively small grammar, create something that has millions of possible combinations and possible completions, which is fun. That's kind of the point. Which is also which is logically the same kind of thing that's happening in House of Dust. So as I rolled this several times, a white duck of the sea is called Mia, the gray kitten of the cloud is called Chiaki. So yeah, that's how it goes. In this case, this I'm not going to go through the rest of this, but just make sure I strongly encourage you to try it out yourself. You can try it out in this little editor here. It's an interactive tutorial. The modifiers can be really useful in terms of parts of speech and, well, not parts of speech, but in terms of getting the correct indefinite article at the beginning of a word, a versus an. It has capitalization. You can also pluralize. So nice little things that are in here with a little kind of modifier on it. If you get more complicated stuff, you can also have it remember choices. This syntax is kind of wonky, I think. It's hard to use, and you really won't need it for the House of Dust exercise, but you might for more complicated things if you choose to do something like this for the book project, for example, which many people typically do for this class. So quite a lot here. I strongly recommend going all the way through this tutorial before moving on. Okay, so we're not going to actually be using it in purpose of, we're not going to be making a bot with this unless you want to, just because, yes, there is cheap-bots done quick no longer works, but there is cheapbots.suite.com, which is a version of this, a version of cheapbots done quick, but for Mastodon. And if you don't know what Mastodon is, I'm not going to go into it now, but it is a thing that is kind of like Twitter, but open and different. And cheapbots.suite is meant to make a bot with that. The idea is you first create an account, a bot account with a Mastodon instance, and then you sign into that from here, and then you construct your grammar in a very similar way to what you can do in the on your own. But whether you want to do that or not, up to you. Okay, let's talk about what Tracery looks like when you're coding with it, and this is it basically. So whenever you're using JavaScript and you're importing the Tracery library, which I have on another slide, it involves just really two special functions or methods of the Tracery library object that is imported whenever you load the source, when you load the script into the source. And it does just a couple of special looking things. So the first is this bit here. It says let grammar equal trace. So I'm creating something called grammar, which is using the create grammar method of the Tracery library. And within these parentheses, that's where the Tracery grammar grows. So that's the part. So if I switch back to here for a second, so this is the grammar, like this bit in here, like this is what would go inside of where the blue text is here. That's the location of this Tracery grammar, right? It has to be completely correct. If there are any syntactical errors in here, it will break. And JSON is pretty fussy. Like you do have to get it just right. You do have to make sure that each element is separated with commas. If you do get errors, you'll see them in the JavaScript console. But even then, it's sometimes hard to kind of figure out what it is. If you have an issue like this where it's not working, you can't find it, send me your code and maybe I can see it. But it's something that it can be an issue. So make sure you're paying attention to where the quote marks and the commas are supposed to go, and you should be fine. But then once you've got your grammar created, the term that Tracery uses is flatten. So you've created a grammar, and then each instance of it, each roll of it, each time you want to see it, is produced from the flatten method. So you flatten that grammar into a string, and then you can do anything you want with that string. Typically, you're going to display it, print it somehow, so that's possible here. This code above me just creates a string called poem by flattening the origin, which is the conventional starting point for a Tracery grammar. Okay, so kind of abstract still a little bit. Let's look at it here in terms of what it would look like altogether in code. This view's a little bit hidden. Let me just slide that down. So in your code, in a JavaScript context like a p5.js sketch, or not, you don't have to have p5.js for this. This is a totally separate library. You could create a grammar like this one, like grammar equal tracery.create grammar, and then here's my grammar that's defining materials for a house to be made of, and then the origin is just the first line of the poem, origin, a house of, and then hash marks material. So down here when I want to create that poem, really it's just one line of the poem, but I'm calling it poem here. I just do grammar.flatten and then origin. And that tells the Tracery code to do that operation of replacing, of trying to complete that formal grammar, going, if you think back to the context-free grammar rules that Chomsky gave us. So that's the operation, or this is what it looks like in theory, or well, in practical. This is a little bit practical, but let's get even more practical and take a look at what it looks like in the context of completing the houses of dust exercise. So I'm going to switch to my code layout here and switch some things so I can see them. So on my left, I've got my code, Sublime Text Editor open on my repository, Creative Coding repository, and on the right, I've just got a page open, and I'll show you which page it is. So it's in my repository. I'm going to folder week 4 folder, and then 4.2 houses of dust. And first of all, let's take a look at index.html, and we will then also be working on sketch.js. But index.html is, it's a typical index.html file for this, with one difference. You do need to still delete line 6 or comment it out. Still sorry about that. It's something that we don't need, but it's causing problems, so just delete it. And the bit that adds Tracery is actually right behind me here. This is, if you notice, it's similar to this line 5. This is loading the Tracery library from a remote server. This is jsdeliver.net, just a different content delivery network. Cloudflare is a content delivery network, so it's JSDeliver. This just basically loads the Tracery library into your code without you having to do anything else. It's just sort of there, and then you can use it. This is the same thing that's happening with p5.js. Don't really need to get into details with that, but just know that you do need to keep that line 10 intact. It needs to be working, or else you won't have Tracery. You won't be able to use it. So make sure you save changes. And then, of course, sketch.js is where we're going to do the actual work of building this library, building our houses of dust example. So as I like to work here, I'm going to have my code on the left and make changes, save it, refresh on the right, and see if it worked. So first of all, I recommend a couple of things. Go ahead and make a string variable to contain your poem. And I'm going to do a kind of simple version of this on this video here, There are other ways you could approach this, and I am going to get you kind of like 3/4 of the way there in this video. You need to take it the last fourth, and some of that might involve refactoring a couple of basic assumptions that I'm doing here. It may not. There may be other ways to do it. I'm kind of getting ahead of myself, but I want to insist that you don't just copy what I'm doing here and then think you're done, because this is, I'm going to get you, maybe more like halfway to completing the exercise here. You need to take it that last step. So let me get you started here though, and I'll show you what that is. So like I said, you need to make a new thing. This is a special object called a grammar that Tracery is capable of making. Make sure that you have the curly brackets. So .create grammar is a method, and then you use parentheses to indicate that this is a method that runs as a function. And what it expects as a single parameter is that JSON object that starts and ends with curly brackets. So now that I've got that here, I can start writing my my Tracery grammar code. I'll call the first one origin, and I'll just say a house of, and then I will say material. So House of Dust, as it was originally printed, was of course in all caps because that was the only option in 1967. But what's nice about trying to recreate it here is that I can make my variables lowercase, so it makes it easier for me to see what's text and what's code. So my variables are going to be lowercase, and then the text that you'll see printed in the message are going to be uppercase. So this is going to be, so that I made that first element here, origin, house of materials. I can save and refresh here just to make sure there's no errors, but nothing's going to be appearing yet. I'll go ahead and open my console here just in case errors do pop up. There's a bit of a just generic error here. This error is not going to cause any problems. I hope not. So the I should have tested this before I started recording the video. I don't think that I don't know if that error is going to be a problem. It might be. If it is, I have another way of demonstrating this, and then I'll have to figure out a workaround. But the origin, house of materials, let's make some materials. Notice you have to make sure that you spell it the same way. So material here, and now I'm going to make a list of materials. So I'll just do a couple off the top of my head, and then I'm going to check this error, because now I'm nervous about this error if it's going to cause an issue. Just a couple that I remember. So mud, bricks, leaves, weeds. I think steel was another one. Steel. So this now should be a complete grammar. And I can actually go ahead and test it here. See, like Tracery shows, the reason I was not too worried about this error is that the Tracery module shows up as an option in the console here. I'm actually just going to be testing it here in the console before I try to actually flatten and run it in the sketch, just to more quickly debug this to make sure that I'm not demonstrating something that isn't going to work. So, okay, so what is it? Oh, not Tracery, flattened grammar. Oh, good. Okay, it worked. So that's a relief. So I just coded in here. This is sometimes, I don't know if I've shown you this before, but you can use the console to try things out and see if they will work before you commit them to your script file. Okay, so good. I'm pleased. Right, so this is a sketch, and remember with p5.js, the draw function is running 60 times a second. We don't want that here because we don't want like the stanzas to be constantly changing every 60 times a second, because it would be impossible to read. So what I'm going to do is, you can approach this two ways. For this one, I'm just going to turn off the loop in setup. You could also, I think, do the flattening in setup. That would accomplish the same thing, but I think you also might want to turn the loop back on also, and I'll show you a way to do that after I get this just generating here. So this is where I'm going to do my flattening. I'm going to say poem equals grammar.flatten, and when you call grammar.flatten, you have to give it the name of the symbol that you want it to start with, and I've called it origin here. That's just a convention. You could call it something else, but origin is like the starting point, right? It kind of makes sense. So now I've defined this variable called poem, and this is p5.js, so I need to use the text function within p5.js. I'm going to give poem, which is a string, as the first parameter for the text function, and I will put this at 50. No, I'll do it at 200. And I'm going to go ahead and make the text size nice and big so I can see it. Okay, maybe that was too big. Or maybe I'll just bring it back over here a little bit so I can see it easier. So a house of weeds, great. Of course, I can change the, what is it, text font? Change the font to something. I'm gonna go with, yeah, monospace looks pretty good, or I could do something else like impact. Can I do impact? Okay, I kind of like that too, actually. So you can change the font, whatever, right? I mean, this is, at this point, this is where your choices start to come in, and you can start to make something your own. But that seems to be working. So it's a house of leaves, and if I just refresh it, it'll run it anew, it'll recompile it, it'll reflatten it, and I'll see different options here. If I just sit here and spam the Control R button, and I'll get, I'll get different things. Now, of course, this is supposed to be a generative poem, and I don't want to have to hit spam. I don't want to have to hit the Control R button to see different things. So I'm going to go back here, and I'm going to, instead of turning off the loop, I'm just going to make the loop super slow. So if you go, there's a function we haven't used yet called frame rate, which just lets you determine or just arbitrarily set the frame rate. And this is asking for the number of frames per second. Remember, the default is 60, or it tries for 60. It doesn't always hit 60 exactly, which is something you have to be aware of if you're using that for timing. You can't rely on the frame rate for timing something else, like with the clock time. So that's what we had to do differently with the time function, the time project last week. But setting the frame rate to 1 means that the frame is going to go on its own once a second. Like, it's going to run the draw loop every second. There is a little bit of a delay because whatever you set the frame rate to, there's like an empty frame first. So for example, if I set this to 0.5 as the frame rate, that means it's going to advance the frame every 2 seconds. You'll see that there's a 2-second delay before the sketch gets rendered, before the first frame gets rendered. You can work around that a couple ways. I think you can make a separate function that draws the poem, and then you could call that within setup and then call it again within draw. I think that would be one way to work around that if that's an issue for you, but if not, that's fine. Okay, so this is, like I said, about 50% there. The next part that I'm going to ask you to work on is completing the poem in a way that will actually work and be as close as possible to Alison Knoll's original. You can think of closeness in a couple of ways, but I want it to have as much of the correct content as possible, and you can figure out that content in a couple ways. You can find recordings of her reading from it to see what all of the different options are for those. You can look at some printouts of it, which you can find by Googling online. You can also find that I have created a JavaScript simulation of this poem a few years ago. Nick Montfort has also created a JavaScript simulation of this poem. He actually owns a copy of the original, so he had that to refer to. I didn't, and so if you look at our source code, he has a more accurate grammar, I think, probably than I do. So you can use his grammar, but you'd have to update it and adapt the syntax of it to fit the Tracery grammar. So get that as complete as possible for, actually, I'm going to go back to my other view here so I can talk about this and have something to point to when I'm talking about it. So in today's exercise, yeah, so I have some links to these two things, by the way. Trying to find the link for today's exercise. For the Houses of Dust exercise, the idea is, there it is, that you first make it as accurate as possible, and then push and commit. So first of all, commit and push, make it as close as possible to the original. Hello. Hello. There's a dog visiting me. So commit and push the original, and then make it your own. So that's kind of step, 8. It's not listed as a step, but it is something else you should do. So make sure you do this as well. Make sure you complete a version of this poem that is no longer Alison Knoll's words, but your words. This is similar to the remix exercise that you did yesterday. And once you've finished with that, go back to your source code, view, and in, you can do it either here or probably index.html, add a comment, a code comment, explaining what you did. So explaining your idea for your House of Dust poem and how you think your idea relates to Alison Knowles' idea. How it was inspired by her idea, how it's an homage to her idea, how it's a response, a parody, whatever you want to think of. But explain that here in just a sentence or two, and that will complete your contribution to this. Once that's done, commit and push again, and you'll see both of these versions online in your GitHub repository. I will as well. I'll be able to see what you completed first as your emulation of Alison Knowles, and then as your subsequent remix of your own emulation, if that makes sense. So that's the whole process here for this exercise. So it's a little bit of kind of background stuff that I don't have an easy way to show you, but hopefully my explanation makes sense. But that's the complete thing here. It's not just get it as, just make it do House of Dust. Don't make it just do what I showed you just now, but get it as complete as possible first, and then modify it to make it your own. Commit and push. That's commit and push the first one when it's a complete emulation. Commit and push the final one whenever it's your own. So hopefully that all makes sense. This is an interesting project, and I hope that it was helpful to look at that context with Alison Knowles and see how you can use Tracery to accomplish something similar. That's the video for today. If you have questions, please ask in Discord. This week working with text is a bit different. I think it's to me a bit more familiar than working with some of the graphical stuff in p5.js, but I still think it's a lot of fun. So I look forward to seeing what you come up with. Let me know if I can help with anything, and I will see you tomorrow with another video and another set of ideas. Happy coding.